Did you know there are 6 people up in space right now? Kind of crazy to think about, huh? We've been visiting space for decades now, but what if we weren't just visitors? What if we were born and raised out there?
Fascinating question.
Really makes you think, how would growing up in zero G change us? I mean, would we even be human in the same way?
Yeah,
So that's what we're going to be diving into today, folks. We're going to be exploring the really fascinating, sometimes kind of weird ways our bodies might adapt to a whole life beyond Earth.
definitely. And it gets right to the heart of what it means to be human. We often talk about zero gravity, but it's actually more accurate to say zero G, that feeling of weightlessness. It's actually from constantly falling around the Earth.
Wait, so they're IS gravity. We just don't feel it. That seems a little, I don't know, counterintuitive.
Exactly. Imagine, like, if you built a tower all the way up to the International Space Station, you'd actually feel Earth's gravity at the top.
Wow.
But here's the thing. The ISS is zooming past at 17,000 miles per hour as it falls around Earth. That's what creates that sensation of weightlessness.
So it's kind of like falling forever,
Yeah,
but without ever hitting the ground.
pretty much.
Okay, so what does that constant free fall do to our bodies, especially if someone was born into that environment?
Well, gravity plays a really, really crucial role in our development here on Earth.
Right.
Take, for example, just the simple act of conception.
Okay.
Even something as basic as hugging.
Yeah.
Hugging becomes a logistical challenge in zero G.
Right.
I mean, someone even invented something called the two-suit, specifically for intimacy in space.
The two-suit.
Mm.
Wow. That's wild. But even if we solve the logistical hurdles, is conception even, I don't know, guaranteed to work the same way out there?
That's one of the big unknowns. Studies have shown that sperm behavior actually changes in zero G, but we need more research to really understand how that affects conception itself.
That makes sense.
And even if a space baby did get conceived, think about their development, for example. The vestibular system in the inner ear relies on gravity for balance and orientation.
So in a place where, like, up and down are more relative, a developing child's sense of balance would be totally thrown off.
Exactly.
Yeah.
In zero G, the fluid in that system doesn't settle properly, which leads to space adaptation syndrome.
Oh, right.
It's basically nausea, disorientation, almost like constant motion sickness. It affects like about half of all astronauts.
Wow. Well, I get carsick on a winding road. I can't even imagine that 24/7. It seems like our dependence on gravity runs deeper than we realize.
It really does. And it's not just the inner ear. Think about like bodily fluids. On Earth, gravity pulls them down.
Right.
But in space, they distribute more evenly. That's why astronauts get those puffy faces and bird legs.
Well, it's not just a cosmetic thing either, right?
Nope.
I remember reading about astronauts having vision problems because of the fluid shift.
You're right. Studies have actually found optic nerve swelling and even flattening of the eyeball because of the increased fluid pressure in the head.
Well,
And then you have the impact on the skeletal and muscular systems as well.
yeah, astronauts have to exercise constantly in space, right?
Right.
Is that just to maintain their fitness, or is there a more fundamental reason?
It's crucial for counteracting bone and muscle atrophy. Without gravity to work against, our bodies actually start breaking down those tissues.
Oh.
Like astronauts can lose 1% of their bone mass per month and 5% of certain muscle mass every month.
Wow, that's a lot.
It is.
So a child growing up in space, they might develop quite differently than someone here on Earth. Would they like have weaker bones, thinner limbs? Maybe.
It's definitely a possibility.
Okay.
And this brings us to the potentially even larger concern of radiation exposure. Earth's atmosphere shields us, but in space, astronauts are constantly bombarded with radiation.
Yeah.
And there have even been studies on mice that suggest links between space radiation and Alzheimer's-like brain changes.
Yikes.
So it's a serious consideration for long-term space habitation, especially for developing children.
Yeah, definitely. This is a lot to take in. We've only kind of scratched the surface of the physiological challenges, and I'm already wondering about the psychological impacts, too.
Yeah.
Sounds like for every answer we find, 10 more questions pop up.
It's true, and that's what makes this also fascinating.
Right.
We're not just exploring the limits of the human body, but also what it means to be human, outside the environment we evolved in.
Absolutely. And we've covered conception, fluid shifts, bone loss, and radiation, all tied to this idea of adapting to a gravity-free environment. But we haven't even touched on like the psychological effects
Right.
or what a space baby might actually look like.
Yeah, it's true. The psychological aspect is huge. We often focus on the physical challenges, but the mental and emotional toll of space travel, I mean, it can be pretty significant.
Right. Yeah. Being millions of miles from home in a confined space,
Yeah.
constantly aware of all the risks. I mean, it's got to take a toll. And what about a child, right? Growing up in that kind of environment, how would their psychology be shaped?
Well, there's actually some interesting research from the South Pole.
Okay.
It offers like a similar level of isolation to space, and scientists working there actually experience compromised immune systems. Fewer T cells, probably due to the stress and isolation.
Really? So on top of everything else, a space baby might have a weaker immune system,
Hmm.
more susceptible to infections.
It's a real concern, especially for like a developing immune system. It's still learning to fight off threats.
Right.
The space environment could significantly impact that whole learning process.
Wow. So, okay, let's get back to the big question then. What might a space baby actually look like?
Right.
Taller, with thinner limbs and weaker muscles? Maybe a puffy face from all that fluid shift we talked about? I
Yeah.
mean, it's starting to sound like a character from like a sci-fi novel.
We have to remember, though, that a lot of this is still speculation.
Right.
We only have limited data on the long-term effects of space on, like, human development.
Yeah, that's true.
But based on what we do know, a space baby, yeah, they might actually be taller than their Earthbound counterparts.
Really? See, that's what I don't get. We're
Yeah.
just talking about bone loss, right? How could they be taller if their bones are weaker?
It's a fascinating paradox. You see, without gravity compressing the spine, astronauts can actually grow taller in space,
Huh.
sometimes by like as much as 3%.
Wow.
Yeah, and that could actually mean like a really significant height difference over a lifetime.
So, okay, picture this then. A lanky teenager just like floating around a space station, maybe with weaker muscles, right?
Mm-hmm.
What about their bones, though? Would they be more fragile, too?
We can look to certain conditions on Earth for potential clues, I think.
Okay.
For example, rickets. It's a bone disease caused by vitamin D deficiency,
Right.
and it can actually lead to skeletal deformities. A space baby's bones, yeah, they might develop similarly to someone with rickets, but for a totally different reason. The absence of gravity's influence.
So the result could be similar, though. Weaker bones, prone to fractures.
Yeah.
Maybe even some, like, unusual growth pattern.
Yeah, exactly.
It's incredible how adapted we are to Earth's gravity and how much it, like, shapes us.
It really does highlight the vast knowledge gap we still have when it comes to human physiology beyond beyond our planet.
Right.
We still don't even know if healthy fetal development is even possible in a zero-G environment.
Yeah, it's mind-boggling to think about all of the unknowns. Like, if humanity ever establishes permanent settlements in space, I mean, what kind of adaptations would we see over generations? Would future space-born humans look drastically different from us?
That's the big question, isn't it?
Yeah.
But amidst all of these challenges, I think there's also this certain poetic beauty, I guess I'd call it.
Okay.
Our source material makes a really fascinating comparison, I thought, between humans and plankton.
Oh, yeah, I remember that. Both are wanderers in their respective environments.
Right. Plankton drift with the ocean currents. And humans, we are just like driven to explore this vastness of space.
It's true. Millions of plankton in the ocean, right? Each just a tiny speck, yet collectively visible even from space.
It's amazing.
And then us venturing further and further from our home planet. I don't know, it's pretty profound when you think about it.
It makes you wonder, are we just like a different kind of plankton on a cosmic scale?
Whoa. Yeah, no, that's a really profound thought. But okay, before we get too lost in the philosophical implications here, let's come back to the maybe a little more immediate realities of space travel.
Sure.
We've talked about all the physical adaptations, right?
Yeah.
The radiation risk. But there's another elephant in the room, isn't there?
You're thinking of the psychological impact again.
Yeah, exactly. The mental and emotional challenges of like living in such an extreme and isolated environment.
Right.
I mean, even something as simple as crying is different in space.
Right. Yes. Astronaut Chris Hadfield, he did that demonstration of how tears just kind of like pool up on your face because of the lack of gravity.
Right.
It's a striking image, really.
Yeah.
It highlights how even these like really basic human experiences are just altered in space.
Yeah, it's wild. It really highlights those psychological challenges that we've been talking about.
Yeah.
Astronauts are, I mean, they're not just scientists and engineers.
Right.
They're human beings facing some really extraordinary mental and emotional challenges up there.
It's true. And it's easy to, get caught up in all the physics and biology of space travel
Yeah,
and kind of forget about that human element. You know what I mean?
absolutely.
Like, just imagine the isolation, millions of miles away from home, limited contact with your loved ones, constantly aware of the risks involved, living in a really confined space, and just the lack of those familiar sensory experiences we have down here.
It's like this constant state of sensory deprivation almost, right?
Yeah.
On top of all the other stresses they're facing. How do they even cope with all of that?
Well, they go through, pretty rigorous psychological screening and training,
Right.
but the long-term effects of deep space travel on, like, the human psyche, they're still largely unknown.
Yeah.
I mean, it's a frontier we're only beginning to really explore.
And for a child raised in that environment,
Yeah.
it's not just about coping, right? It's about their development.
Mhm.
Their whole understanding of the world would be shaped by these unique conditions they're experiencing.
For sure. I mean, their concept of personal space, their perception of danger, their social interactions,
Yeah.
all of these things could be fundamentally different from someone raised on Earth, you know?
Yeah, totally.
I mean, imagine a child who has never even felt the wind on their skin or the warmth of the sun.
Right. It's almost like they'd be growing up in a different reality altogether.
Yeah,
Wouldn't that in turn influence their psychological development as well?
absolutely. Even something as simple as crying, which we just touched on, could have completely different emotional associations for a space baby, right? I mean, if they've never felt tears actually roll down their cheeks, would they connect, crying with sadness or relief in the same way we do?
That's a great point.
Hmm.
It makes you wonder, could a space baby like develop new ways of expressing emotions that we haven't even, I don't know, considered?
That's a really fascinating question, I think, and it kind of speaks to the broader point we've been exploring throughout this whole deep dive, really.
Okay.
Space isn't just a physical challenge, it challenges our understanding of what it means to be human, you know?
So where does that leave us then? I mean, we've talked about the potential physical adaptations, the radiation risks, the psychological unknowns. What's the takeaway message here for our listener? What should they be thinking about as they, continue to learn about all this space exploration stuff?
Well, I think the biggest takeaway is this: a sense of awe and wonder, really.
Yeah.
We're just scratching the surface of what's possible and what it all means for humanity, as we venture beyond our home planet.
Yeah, I think we tend to get caught up on like the technological hurdles,
Right.
but it's really about understanding ourselves, right? How we adapt, how we evolve, how we define what it means to be human in a completely new environment.
Absolutely. The prospect of raising a child in space, yeah, it's daunting,
Right.
but it also opens up like a whole universe of possibilities.
Yeah.
I mean, we might discover new forms of human expression, new ways of interacting with the world,
Right.
even new ways of understanding consciousness itself.
It's a journey of discovery that's just beginning.
Hmm.
And it's a journey that, goes beyond simply reaching new planets.
Yeah.
It's about pushing the boundaries of our own understanding of what's possible.
I completely agree. So, to our listener out there, we'll leave you with this thought. As we venture further out into the cosmos, let's remember that the greatest frontier we're really exploring isn't space itself, but the boundless potential that we have within ourselves.